let's now consider some more multi-step processes. All right, and so before we were kind of considering simple sort of events that were either mutually exclusive or were independent, such that the occurrence of one outcome did not affect the occurrence of another one. Now, let's relax some of those assumptions and let's start taking a look at more complicated events where there are correlations or relationships between the different outcomes. Now, in order to formalize our discussion, I want to define a couple of more terms. And so when we talk about the conditional probability, what we're talking about is that, what is the probability of some sort of outcome given that another outcome has occurred? And so the way that we would write it would be something like this. And so by this, what we're saying is we're looking at what is the outcome or probability of outcome B given that outcome A has occurred. So probability of outcome B given that A occurred. Okay? All right, so that's the definition of a conditional probability. All right, so another sort of term I want to define is the joint probability. Okay, and so here, what we would look at is the probability that some outcome A and B occur, which is something we looked at before, right? And so a way we could abbreviate this is just by saying PAB, right? And so the definition of this joint probability that A and B occurred. Right? And so this is something that we looked at calculating earlier, but in our previous calculations, we assumed that the outcomes were independent. Now, we're not going to make that assumption. Right? And so if we want to calculate the joint probability that A and B occur, the sort of general formula for it would be something that looks like this. So we have the probability that A occurs, followed by the conditional probability of B occurring, given that A occurred. Right? So what we did here is we split it up into two parts again. Right? So first, we just considered the probability that one of the outcomes occurred. In this case, we chose A. And then once we had that, we then considered the probability that B occurs given that A has already happened. Right? And so the order that we have here, the first event that occurs, we would refer to this as the a priori event. Right? So this is Latin for the thing that happens first. And then the second probability here would be the a posteriori. P-O-S-T-E-R-I-O-R-I. So that's the event that happens afterwards. Okay? Now, to kind of make things match up to what we talked about before, here this is just the most general definition. But in the specialized case that A and B are independent, then the probability of B occurring won't actually be affected by A at all, right? And so then our PBA would just be equal to the probability of B. All right, so that's what happens in the case that things are independent. So when we're rolling die and we're just looking at the outcomes of different die rolls, those would be independent events. But now let's consider a case where the B outcome is not independent of the A outcome. And so let's consider an example where we're taking balls out of a barrel. Right? And this barrel, it contains balls with two different colors. Right? There are two green balls in there and one red ball. Okay? And so what happens, or the scenario we're going to consider, is a case where we first take a ball out of the barrel and it's green. So if a green ball is chosen first, and then once we pick the ball, we also remove it from the barrel. So if a green ball is chosen and removed on our first draw, what we want to calculate is what is the probability of selecting another green ball, selecting on our second draw. Okay. All right, and so using the formalism that we defined here, we could say, what is the probability that upon drawing a green ball on the first draw, that we draw a green ball on the second draw, right? After removing that first green ball. The way we would write this is we would first have the probability of selecting that first green ball, and then we would multiply it by the conditional probability that we draw another green ball after that first green ball has been drawn. Okay? And so let's think about this. Our barrel initially contains 3 balls. What's the probability, if there's 2 green balls and 1 red ball for a total of 3 balls? What is the probability we draw a green ball on the first try? Right? That would be 2 out of 3. All right, after we draw that first green ball, we remove it, and now there's only 2 balls left in the barrel. 1 green, 1 red. And so the probability of drawing a green ball in this case would be 1/2. And so the overall probability of drawing a green ball on the first and second draw would be equal to 1/3. There's a 1/3 chance of doing that. Okay? And so that's how you could use, conditional and joint probabilities to calculate the probability of this sort of multi-step process. Other sorts of general definitions I want to go over. For mutually exclusive events, we talked about using the addition rule. But now I want to talk about the addition rule for the case where we don't have mutually exclusive events. And so here, to calculate the probability that A or B occurs, where this little U that I'm drawing here means union, what we would do is we would add up the probabilities of either A or B occurring, right? And so there's the probability that only A occurs and B does not, or that B occurs and A does not. But there's also the probability that both A and B occur, right? And so the way we could kind of visualize this happening is as a Venn diagram, where the circle on the left represents outcome A, circle on the right represents outcome B, and we see there's overlap between the two. All right? And so what we want to do in order to calculate this probability is we want to not overcount, and we want to get rid of the overlapping section of the Venn diagram. So to do that, for our general addition rule, we would subtract off the sum here the case where both A and B occur, where this little upside down U represents the intersection of the two events. Okay? Alright, so that's the general addition rule. And the last thing I want to define or discuss is when you're adding joint probabilities. Okay? So here we talked about, what's the probability of A and B occurring, right? And we kind of split it up into two processes. But here, let's just say we want to calculate the probability of just B occurring, right? And so there's kind of two scenarios where this could happen, right? So B can occur after A has occurred, or B can occur in the case where A does not occur, right? So to kind of articulate what I'm trying to describe, to calculate the probability of B, we would do it like this. P A prime, P B A prime, right? So in this first term, we're calculating the probability that B occurs after A occurs. Right? And in the second term, we're looking at the probability that A does not occur, but B still happens. And this little prime here just means that A does not happen. Okay? All right. And so those are just a couple of definitions with regards to more complex situations where you need to calculate a probability.